In this second video, we'll be discussing the science of studying the human population. So just to look again, here's our human population growth graph as a review from about what would be 10,000 years ago, right around to 4 to 5,000 years ago. The entire worldwide human population was following a hunter-gatherer lifestyle. We then had a switch, and that switch had some overlap with hunter-gatherers depending on where on Earth you were. From about 3,000 years ago, right up to about, 5,000 years ago to 500 years ago, the majority of the human population followed an agricultural lifestyle. This is where most people were farming, growing their own food, storing their own food. After that agricultural lifestyle, we had what is known as the Industrial Revolution and influences and changes in technologies with mass productions of goods. This is really when the growth is going to start on this graph. Notice this is where the uptick and the growth rate is starting. The slope of that line is increasing through time. Now, the agricultural revolution led to what we call the Green Revolution in the 1960s, which were developments in new agricultural practices that more than doubled the food supply in a very short number of years. And this is really exponential growth rate here, exponential. Okay, the population is skyrocketing at this point. Current estimates would show that we're adding about 200,000 people per day to the globe, and so this is a very high interest area as far as studying policy trends for nations worldwide are developed and based on this human population. Just to break down a couple of numbers, China. Population somewhere around 1.3 billion, India 1.1 billion, the U.S. is more in the 300 million range, so much smaller than at least those two countries. Okay, so what have been the key factors in this growth and this expansion of the human population? Basically, at least since the Industrial Revolution, humans have really had a very reliable food supply. So processes of storing and saving food and planning food for the future has been really key in improving our situation, increasing our growth. Improved sanitation, so we're talking about removal of things like sewage and garbage. Now this has done a couple things. It's reduced diseases, basically, a couple of ways. So a decrease in disease. When you don't have raw sewage, you get rid of diseases like cholera. Lack of garbage decreases pests like rodents and fleas, etc., that also carry disease. And then we tie that together, at least since the Industrial Revolution, with modern medication and improved medicine and health care, we've increased the life expectancy and longevity of people. So people are living longer. People are receiving health care, things like antibiotics and vaccines, okay, that are making them resistant to diseases that maybe used to kill them, etc. And so basically what we've done is we've removed all those, especially the density-dependent limiting factors, okay? Those are the ones that rely on the size of the population. Those have been removed from the human population. And so we're not responding. We're showing that exponential shape because we're not responding to those limiting factors. If we were, we would probably look more like this green curve. Remember that green curve? That's logistic growth, right? That's when a population is responding to its limiting factors. But, as you can see or saw, at least in the previous slide, the human population is that red curve, that exponential growth pattern. So demography is the science of studying population growth. And so if you were a demographer, you would be a scientist that studies populations. Okay, and so demographics, this is the study of the characteristics of a given population. Okay, so what are demographers interested in? They're interested in how that population will change over time. Basically, what do you care about? Well, you have to think about the population growth equation. You care about births, you care about deaths, you care about immigration, and you care about emigration. Okay, and so that's what you're interested in if you're studying demography. Okay, and so what people who study demography do is they examine what's called the age structure in order to predict how that population will change in the future. What an age structure is it's the number of people that live or are occupying a different age group in the population. Basically, you want to know how many young people there are, how many older people there are. And based on that information, you can look at whether that population should be shrinking or growing in the future. And so when you examine age structure as a demographer, you create what are called age structure diagrams. Okay, these are basically histograms. You guys have pictures of these in your packet, and what they are graphs of the males and the females at different age groups within a population. So the blue here shows ages 0 to 14, so that's the young people. The yellow then shows ages 15 to 44, okay, so that's people in middle age, and then the red or orange portion here, this is 45 to 85 plus. Okay, now what is on then that's your y-axis, your x-axis in these age structure diagrams is essentially the number of people. Okay, and so the wider it is, so like wider down here means more people, and skinnier up here means fewer people at that age range. Okay, and so what I want to do is go through and just look at a couple of age structure diagrams for different countries. We'll see some patterns here. So this first diagram that has this very triangular shape, which basically means a lot of young people and very few old people. This is very characteristic of countries like Guatemala, Nigeria, Saudi Arabia, basically developing countries. What this is it's a country that has a lot of very young people. So basically, the people in this range had a lot of children. Okay, and if you would have looked at this graph 15 years ago, you would have said all the people in this range had a lot of children. And so what this shows is basically it's a country that each generation they're adding more and more. And so what you have to think of as a demographer is what is this generation going to do? Are they going to continue to have a lot of children, in which case the graph will continue that triangular shape, or are they going to change their pattern? When you see graphs like this, even if this blue generation has the same number of children as their parents, the population is going to grow again. Okay. Now, our country, the United States, Australia, Canada, okay, a little bit more developed countries, we tend to have less of a triangle. So basically the middle agers just about equal the young people. And what this is showing is a relatively constant population. So through time, these people had about the same number of children, okay, as their parents did. Okay. Now, obviously, you're always going to have fewer people up at the top. Why would you be having fewer people up at the top? Well, because these people are doing what? Well, they tend to be dying, usually of old age, but sometimes of diseases, etc. Now, when we switch modes and we begin to look at especially a lot of European countries like Spain and Australia, or even in an extreme, Germany and Bulgaria, these countries, they lose that triangular shape. They either get a straight up and down sort of shape to their age structure or a V shape. Okay? Now, what is going on here is that these would be, at least straight up and down, this is a zero growth population. Okay? So whereas the United States and Guatemala, etc., when they had those triangles, okay, that's a population that's going to be growing in the future. Okay, so growing. Straight up and down, this is going to be zero growth. So if you graph the population through time, okay, the populations that have that triangle shape, they're going to increase through time. Populations that have this straight up and down shape, they're going to be stable through time. Okay, basically each generation, so this generation is just replacing itself, equal numbers. Now, the third case is going to be countries like Bulgaria, Germany, and Sweden, which actually, with that inverted V shape, what's happening is each generation is having fewer and fewer children, so they have a negative slope to their line, or a negative population growth through time. Remember, this would be the number of individuals, this would be time, okay? And so their line would be that purple line, decreasing through time. Each generation is having fewer and fewer kids. And so, I mean, there's things in the news right now where Germany's actually wants to increase their population. The easiest way to do that is to encourage both births, so they're actually encouraging people to have more children, and immigration, allowing more people to arrive in the country. Okay, so what factors influence that change? Basically, as countries go through the stages and the processes of development, countries that are new tend to have high birth rates. Okay, and basically why that is people are settling in a new area, they're developing an economy, etc. But as a country gets older, as all the towns are filled in, the buildings are taken up, the housing becomes stable, basically countries' birth rates tend to start equaling their death rates, and so growth slows. Okay, currently what we're seeing on Earth, though, is a lot of countries that are still going through this process of development. And so if you go to somewhere like India or China or Guatemala, their birth rate is much greater than their death rate. Okay, so basically, on a number of countries, there's more countries right now that are growing than are shrinking. What we would expect to see in the future, okay, so 200 years from now, is that as those countries become modernized, their birth rates and their death rates fall, okay, and growth tends to stabilize or reduce. And we have evidence of that in countries like Japan, the U.S., most of Europe, like Germany that we're talking about. As they become more developed, growth slows. Basically, people get jobs, they start having fewer children, etc. And so this is all this is leading us to talk about what's called the fertility rate. Right? Fertility is a number of children that a couple is having, basically. So number of kids, okay? And we have an idea of what's called a replacement level fertility. This is basically the average number of children worldwide that a couple would have that would result in a stable population. So this is not growth, but also not shrinking. So just keeping the same numbers. Now that replacement level fertility actually turns out to be 2.1 children per couple, okay? And so basically, why is that number greater than 2, right? So if a man and woman both have 2 kids, when they die, there's 2 kids left. Why 2.1? That's an average number, first of all, so you get that 0.1. But you have to realize not all children make it to adulthood, especially worldwide where we have high rates of disease and in other countries, etc. Okay, so here's just some current growth rates for some countries around the world. Average world is 2.47, so we're above that replacement level, which means we're going to be growing. The U.S. is 2.06. That's pretty much a stable population, and we really haven't changed much in recent years. Japan, 1.39, so they're shrinking. But then we start to look at countries like Somalia, Rwanda, with fertility levels 6.25, not 6.25 kids per children. Rwanda 4.81. That's an average couple having close to 5 children. That's very much a growing population. Okay, and so here's how you graph birth and death rates versus time, or how you would predict birth and death rates would change through time. Okay, as a country becomes more developed, these rates are going to decrease. Population will have grown and then will stabilize off as those birth and death rates fall. Okay, so what will happen in the future? Well, that's what we're going to have to talk about as we go on. I'm unable to tell you what will end up happening with the human population worldwide. We will be talking in this unit about the impacts on the environment and possible solutions, steps that you can take to reduce those impacts.